Good afternoon and welcome to the Environmental Echo. This is PWGC's monthly podcast. I'm your host, Paul Boyce, CEO and President, and today we have our first podcast of the new year. I mean, we're a little late in taking off here. It's getting towards the end of January, but as always, we're trying to bring you guys some interesting and exciting topics, and that will be coming up out across or through the rest of the year as well. But today we've got the topic that's always important, especially to the Long Island region. We've hit on this before in our past podcast, and it's going to have to do with wastewater and water quality. And today we have Environmental One Corp, which is low pressure sewer guys, which we're real excited to get in here and talk to, and we'll make a quick intro on that. But before we get started, I do want to just remind our listeners, if you guys want to reach out to us, the best way to get a hold of us is through our website, which is www.pwgrocer.com/podcast. If you have questions, comments, thoughts, ideas, or anything you want to share with us, certainly reach out to us. We've got guys that are manning the booth back home, so to speak, and we'll get back to you in a responsive manner. But also, if you have ideas for topics or guests or any other ideas, we're open to listening to them, and we hope to hear from you. But back to today's topic, as I said, Environmental One Corp. We've got Chris Nedwick.
It's actually Environment One.
Oh,
I just wanted to clarify.
Oh yeah,
I'm not trying to be difficult.
Well, you know what? I usually refer to you guys as E1.
Even better.
That's why. So, Chris, I apologize. We'll get that sorted out. It's Environment One, but their nickname, if you will, is E1 Corp or E1. The low pressure sewer guys, as I said, they're manufacturers and suppliers of terrific equipment to help take care of wastewater concerns, not only here in Long Island, but across, the world, actually.
That's right.
But Chris Nedwick, he is their National Sales Development Manager. And as I said, the topic today is going to be wastewater management. So, Chris, you started out as a native Long Islander. Way back when, and you began your career in wastewater industry in 2007, yeah?
Sometime around there, yeah.
As a field service tech and an operations professional, and you were able to travel throughout the United States overseeing numerous installations and startups, as well as implementation processes related to these low-pressure sewer systems, or as they're known as LPS, huh, Brian?
Yep.
Since then, Chris, you've served with E1 as an inside sales specialist and contributed directly to the implementation of hundreds of these types of projects, as I said, not only throughout the United States, but throughout the entire world, which is quite impressive. You're currently overseeing the implementation of projects in Suffolk County, which is where we're recording the podcast from today. And you are connecting thousands of, in Suffolk County, we're going to be hooking up thousands of homes to these types of systems, which we'll be sharing with our listeners what these are and how they work in just a moment. But during his career, Chris has conducted more than 350 seminars and educational events for engineers and operators in dozens of markets regarding the LPS system and its implementation. Outside of E1, or I should say Environment One Corp, now that I got that correct. Again, I've always called you guys E1. Thanks for setting me straight. Chris is an accomplished guitarist, lover of muscle cars, and above all else, he's a father of two boys, and Christopher and Joseph, and he's husband to wife of Julie. Chris, welcome.
Thank you.
Glad to have you today.
That makes me sound way more important than I am, basically, but...
Come on. And also, we've got a repeat offender here, as I like to call him. We've got Bryan Grogan, who is our senior vice president and heads up our engineering unit back at PWGC. Bryan, thanks for joining us also.
Thanks, Paul. Thanks for having me.
All right. Well, guys, let's get right into the environmental echo here. Chris, there has been a big push on Long Island to reduce the negative effects or impacts of nitrogen loading in our groundwater and surface waters. One of these ways that's been discussed is through sewering. Can you tell our listeners how E1 is working with local municipalities to address this problem?
Yeah, I mean, I would start that actually by just kind of going back in history a little bit. We have a project here called the Village of Patchogue, which dates back really to the design portion of that. Dates back to the late 90s, early 2000s, I think, is when it was finally implemented. But that would be considered the first system that we have here in Long Island. And from that point, slowly, over time, we've kind of built off of that. And we are working directly with Suffolk County DPW and other stakeholders, including the Suffolk County Department of Health Services as well. A lot of local engineers and builder developers and other people who are involved in the industry. But we're at a point now where we've turned a corner, and we're seeing this this technology adopted on a wide scale, like we never have before, in part because, we feel it's perfectly suited to deal with the challenges that Suffolk County faces. So
that's a good start. So what is a low pressure sewer? Our listeners, gals that have been following us, they've heard us talk about sewers, and we've even mentioned the LPS, but I think it's time to really give them a little bit of a better understanding of what we mean when we're talking about this.
Absolutely. So we're different. We are the founder of the technology, right? We invented the technology back in the late 60s. It really stems from a concept that was developed in the mid-1950s by a gentleman named Dr. Gordon Fair, who was with Harvard University. And he was a visionary who understood that in order for the United States to develop fully and realize its full potential, particularly in the Northeast, that they'd have to get rid of combined sewers. And one of the things that he looked at was the concept of having a pipe within a pipe. So just imagine an existing pipe that's very big, right? It's for a combined system, and you're putting a smaller diameter pressurized pipe inside of that. That concept proved to be not feasible, if you will, not cost effective. As you can imagine, you would run into a lot of issues doing that. However, the concept of a small diameter pressurized pipe survived and was kind of kicked around mostly in academic circles. Flash forward, to the mid-'60s, and the American Society of Civil Engineers basically were tasked by the United States government. This predates the Clean Water, Clean Air, all the regulatory agencies essentially. So this is coming directly probably from the Department of Interior. But they put this call to action out to the ASCE to come up with a way of sewering that's cost effective and can be implemented more easily than gravity, frankly. And that's kind of where the technology was born. And they approached General Electric, who at that time was the global leader of a lot of things from an R&D perspective, but also from a manufacturing perspective, particularly when it came to appliances. And GE appointed a team of scientists, if you will, and engineers to look at this idea. And they basically started with the application. They worked backwards. And what they arrived to was the design that we currently use still to this day, which is fully automatic, requires no preventative maintenance. They understood that the asset would have to be located at each home to work and would have to be essentially invisible to the homeowner. So when we look at pressure sewer, we look at it differently. We're not just a grinder pump manufacturer. We deliver optimized systems. And we consider the system itself to be a network of small diameter pipes out in the community, and the grinder pump is the thing that makes it all work. Now, that's different than gravity, which typically would use large diameter pipes and things of that nature. So it's different in the sense that it can be installed at a fraction of the cost of gravity, for example, and it has a light touch on the land.
Yeah, and one thing too, gravity sewers typically need larger regional pump stations to you run from a high point to a low point. Everything flows downhill. You get to a point. Now you need a larger pump station. It needs to be located on property that's typically owned by a municipality, then moves it further down the line, ultimately to the treatment plant. The benefit of a low-pressure sewer is you actually that whole piping network moves all the way through, regardless of what terrain you're in. E1 typically markets themselves as like the all-terrain sewer. It doesn't matter if you're going up, down, left, sideways, get it there. Yep. Again, so that's one of the kind of the bigger differences there. And in terms of the county, we've done gravity sewers before. Southwest Sewer District is all gravity sewers back in early 70s. A lot of dewatering. Again, as Chris said, a lot of big pipes. I mean, the biggest pipe, I think, before you get to Bergen Point is over 96 inches tall. I mean, there
8 feet, right?
Yeah, there were stories of the guys driving the Volkswagen Beetle through it kind of situation. Yeah. Trying to put that kind of pipe in the ground today, we'd have a lot more environmental challenges than we did back in the 70s. Dewatering, things of that nature, what you're going to find, what you have to get out of the way. We're fully developed. Back in the 70s, I mean, we had homes and things, but maybe all of our infrastructure wasn't as far along as it is now. Whereas now with E1, it's low pressure, like Chris said, low pressure diameter pipes. The majority of the pipes in the homes in the residential areas are, between 3 and maybe 8 inches tops. Maybe duplicate 3-inch lines like in Patchogue for expandability. But you're running really small diameter pipe, very low impact to the actual community as a whole.
Excellent. So, Chris, just a little more detail for typical residents here in Suffolk County and elsewhere. There was, pretend I'm John P. homeowner, right? And you said everyone's going to get one of these at their house, right?
Mm-hmm.
So what happens? I'm home. I use the sink or a wash machine, dishwasher, shower. Water goes down the drain. What happens?
So the system is connected to the home typically by a 4-inch gravity line, if you will. We call that the inlet.
Mm-hmm.
Here in Suffolk County, it'll be 6 inches as part of these projects. Anyway, the wastewater, the household wastewater, goes into the wet well portion of the tank. It goes up to a certain point, about, say, 18 inches or so, and the pump kicks on. It's operated by a pressure switch, so it never comes in contact with wastewater. The beautiful thing about that is what we call FOG in the industry, fats, oils, and greases, prohibited items, things that don't belong down the drain. They can't interfere with the operation of the pump. So the system itself, 25-plus year service life is what it's designed for. So they can expect an experience that is not really different than what they have now. There are certain things that do and don't belong down the drain, but that's true with any type of collection system. One time I had a homeowner call me, and he was upset because he was connected to a pressure sewer system, and it meant that he could no longer put his used motor oil down the drain. So, obviously that doesn't belong down any drain. And I only bring that up as an example. I mean, the asset is designed to be invisible from the homeowner. And on the way down here, it's funny, I was thinking about the fact that at one point I was directly managing a territory with about 325 to 350,000 E1s in the system itself. And, they do operate very well for a very long period of time. It wasn't uncommon for a homeowner to call me and say, hey, look, I built this house in 1990. I didn't even know I had one of these pumps. On the one hand, we're never happy when there's a service call, which, by the way, would occur as about every 8 to 10 years of some type of a service call. But the asset itself is designed for 25 plus years. But by the same token, if you build a house in 1990 and you don't even know you have the thing, I always say there's 2 times that people think about infrastructure. The average person is when they have to pay a bill or when it doesn't work. Fortunately, these things work. They're very predictable, and they last for a very long period of time.
So, like you said, the water flows out of the house, goes into the wet well. There's a pump or a grinder pump there, then takes the stuff out of the wet well and sends it off to the sewer.
Correct.
So you've got like maybe hundreds or thousands of these little pump stations in everybody's front yard.
Right.
How does that then maintain the pressure in that sewer that then gets to the plant?
So the lines themselves are optimized. They're sized. We work in conjunction with engineers like Bryan. We've worked with him before on some projects. But we will design the system in such a way that guarantees it's going from point A to point B within a 24-hour period in this part of the country and the world. So the line is a pressurized line, but it's not always under a continual amount of pressure. If it's a small system, there may only be a couple pumps running at any given time. In that case, there wouldn't be a lot of pressure inside there. But we know if we're sizing the system properly that it's going to get what we call retention, which is the amount of time that's in a pipe. Obviously, you guys know what that term means. But we want to make sure it goes from the home to the outfall point. In this case, it might be Bergen Point, right? Wastewater treatment plant. We want to make sure that process happens within 24 hours. So the grinder pump is the thing that makes it all work. So the system itself is the network of pipes out there in the community. The grinder pump is the thing that makes it all operate efficiently and effectively.
All right. So then what are the real advantages of this over, say, more conventional, like you said, the gravity or a vacuum system? Where's the real strength lie in the E1 type or low pressure system?
So Bryan made a really interesting point on a previous podcast, which I'll just kind of use as a segue into this. He's looking at me wondering where I'm going with this.
Which one, huh?
He makes lots of good points.
Yeah.
But when you have existing buildings and existing infrastructure, right, and existing roadways and transportation system, it becomes very difficult to introduce infrastructure retroactively because you're retrofitting it into the community. In this case, if some of these projects had moved forward with gravity, the implications would have been significant. You would have had road closures typically, right? You'd have a lot of noise pollution. You'd have big open trenches and things like that. So a pressurized sewer system is, it's going to reduce all those things. It's going to mitigate those impacts.
Yeah, so like, for example, a lot of the low-pressure installations now have been directionally drilled. So you have directional drilling pits, say, every 1,000 feet, or, sometimes maybe it's 400 feet, depending on what you're kind of going through. But you can see it in, you can drive through in, say, for the Ford River project in Mastic, you can drive down Montauk Highway and you'll see the jacking pits, but it's every 1,000 feet, there's a pit. If that was an open trench gravity sewer, that would have been a 8-foot wide trench, 10 feet deep. And the other thing is everything else has to get out of the way. Gravity sewer basically rules, and anything that's under pressure has to move. Well, that means water, gas. If you have drainage now, we got to adjust things. So you're looking at the cost of moving all of that and the disruption to every other service that's out there. Not to say that low pressure, maybe there's an instance where we need to offset a water main for one reason or another, but it's a handful of times rather than every time. Yeah. And that's when you run into problems. Or in areas like the projects that we have for Oakdale, or anything that's a little more lower lying in elevation wise, where groundwater is elevated, we're going to be dewatering like crazy to get that area dry, to get sewers installed. Now, gravity would be 6, 7, 8 feet of dewatering, and that's a relatively large undertaking, and that's a 24-hour operation. It's not something you just do during the 8 hours of construction time. That pump's running 24/7.
And you got to find a place to dump the water.
Exactly. But with low pressure and directional drilling, you don't need to worry about that. You're not dealing with the dewatering aspect of it. So there's definitely advantages there where you can maneuver around things. I mean, I've seen the directional drilling in operation, and they can steer the head of that directional drill up, down, left, right. They're watching the guys in the back driving it basically, and you can avoid utilities that are there without really having to expose them and really make where they are, but you can very easily avoid it. And it's something that kind of helps keep the speed of the construction going and keep the costs down.
Yeah, one of the questions that you had asked earlier is kind of like, what are we up to? What are we working on in this market now? And I would just cite Ford River, which is ongoing right now. I think there's 477 units that are operational. When I say units, I mean those are homes connected to an operational pressure sewer system. At one point, the contractor there was putting in about 7 to 10 a day. So to Brian's point about efficiency of bringing systems online, that small diameter nature of the system itself makes it impacts a lot of things. So the speed by which you can connect a community, reducing the impacts, as I mentioned. One of the big ones that we usually start with is what we call CapEx, or capital expenditure, right? That's the money up front. We know from experience, and it's not our information, it's third-party information, that an E1 pressure sewer system is going to reduce upfront costs by up to 80%, or even much more in some cases. Even on an ongoing basis, it's very, very cost-effective to operate. And I'm not up here to bash gravity. I mean, there's an appropriate application for every type of technique out there. Downtown Manhattan is a gravity system, right, and rightfully so. But there are pros and cons, and especially where you have an area like Suffolk County that's a dense to semi-dense population, those impacts would be significant. The cost would be significant. I think at one point, going back in time now, I remember reading an article in Water and Waste Digest. It was really just a little blurb, and they estimated that to sewer these projects with gravity would have cost billions, and rightfully so was the calculation. So you're reducing your upfront costs. It's very cost effective to operate once it's installed, and you're also reducing all these other impacts that extensive construction of a gravity system could have on the community.
We hope you enjoyed part 1 of our 2-part series with Environment One's Chris Nedwick and the low-pressure sewer technology offered by his company. Join us for our next episode, where we will learn more about these systems and how they are contributing to improving the environment across the country. Please tune into the next episode, available everywhere March 15th.